we know that the electric field due to any Q at the origin, this is the Q is at the origin. So the source location is 0, 0, 0 at the origin, and this guy is at R. My location is R. I want to find the electric field at R due to a Q at the origin 0, 0, 0. So when I have R minus RQ, this RQ is 0, 0, 0. RQ is going to be 0 vector. Because the Q is at the origin. If I go ahead and do that, I get my electric field to be this expression, right? Q over 4 pi epsilon R square in the direction of R hat being in this direction. So then if I were to find the electric field, which is from infinity to R, where infinity, V at infinity is equal to 0 volts. The ground is defined at infinity. You end up getting Q over 4 pi epsilon R volts. The unit of this is volts. The unit of this is volts per meter square. So what you have is 1 over R square here. It has become 1 over R here. So if this is for a certain charge Q, if I have it at a location RQ, then the voltage, if this is my origin, if this is my RQ, at this point I'm having a charge which is plus Q, then I want to find what is the voltage at R. This is my origin, X and maybe Y. Because of this RQ here, I want to find R minus RQ. Same as that. Instead of square for potential, it becomes simply the magnitude. There is no more square here. So it's 1 over R dependence for voltage and 1 over R square dependence for the electric field. So if you were to increase the distance between 2 points by, let's say, a factor of 2, then the potential is going to go down by half. If you increase by a factor of 4, then the potential difference between them is going to go by a factor of 1/4. Yeah. So again, if you were to have multiple points at different locations, R1, R2, R3, R4, and then find the voltage due to R, then I'm going to find due to this guy, due to this guy, due to this guy, and due to this guy. I need to add them up. The same thing that you did for the electric field again, but now instead of E of R being 1 over 4 pi epsilon sigma I equal to 1 to N Qi over R minus Ri the whole cube times R minus Ri vector. Instead of doing the electric field, which is this, we are doing it for voltage. Now this is the potential, the voltage at a point. Same thing then you can extend to the line integral, the line charge, surface charge, and volume charge.